Yeah. Let me know if you are able to see my screen or not. Um, Give me 1 second. I'm just adding it. Yeah. Are you guys able to see my screen? Yeah, so we were when we were discussing it from educative, the kind of questions or the kind of requirements we were talking about was very basic, like queue creation, send message, receive and delete. So generally if you discuss about CRUD, the interviewer would actually try to categorize you in a like from in his own mind as a junior developer. But when, like, when you start with questions like what will be the message size, will do you want the messages to be consumed repeatedly, these are like these questions technically assumes that what message queue is. The interviewer knows what the message queue is. Both the interviewer knows what are the basic functionalities of message queues. So you don't actually put any stress on that. You directly move on to the advanced consideration or the configuration that you would be taking a look into. So just keep this in mind. Like if you're trying to prepare for a, it depends on the level you are interviewing, or it also depends on like your level of understanding. Based on that, keep this in mind, the kind of questions you are supposed to ask. And also this also depends on the interviewer. If the interviewer is someone who is very senior, you can try to discuss more about specifics of anything. Like it doesn't have to be complicated, but just try to talk about more about numbers with a senior interviewer. And with junior interviewers you can actually try to discuss more like a CRUD functionality, or more like the basic functional part. uh, because like for an experienced interviewer, or for a basically a senior interviewer, this is waste of time, like discussing the basic functionalities and stuff. They just want to read your mind about like what kind of things you consider when you are talking about numbers. It's very tough to come up with just assume something, or just bluff something, and then trying to justify like a wrong assumption. So that is usually they are very good at calling this bluff. So that's why they want to test whether you are taking right numbers, or you are taking a right hypothesis initially, and then you are sticking to that particular assumption. So we will see how we can guess the assumption, or we can try to start with those, and then how we can frame and build upon those. It's not anything like tough or complicated. It's just the way of managing the interview. So Alexu, if you read, it's full of this numbers and full of this kind of questions. So yeah, keep an extra attention on the difference between the way we read it earlier, and how different the language here is. Yeah, that's all. You can go ahead.
Candidate, what's the format and average size of message? Is it text only? Is multimedia allowed? Interviewer, text messages only. Messages are generally measured in the range of kilobytes, kbs. Candidate, can message be repeatedly consumed? Interviewer, yes, messages can be repeatedly consumed by different consumers. Note that this is an added feature. A traditional distributed message queue does not retain a message once it has been successfully delivered to consumer. Therefore, a message cannot be repeatedly consumed in a traditional message queue. Candidate, are messages consumed in the same order they were produced? Interviewer, yes, messages should be consumed in same order they were produced. Note that uh, this is an added feature. A traditional distributed message queue does not usually guarantee delivery order. Candidate, does data needs to be persisted, and what is the data retention? Yes, let's assume data retention is 2 weeks. This is an added feature. A traditional distributed message queue does not retain messages.
Yeah.
Candidate,
So just one thing. Um, so this persistence and data retention, this is part of the data durability that we were discussing.
Why every answer has like so the traditional message queue does not have these feature, but like whatever he's asking, it's like a additional feature to that.
Yeah, so that's the difference. We were talking about plain message queues versus streaming platforms, right? Uh,
Oh, got it. Okay, so they're trying to highlight that event streaming message queue.
yeah, you can assume that. Uh, like,
So when he says, like, for example, like, is it like a hint or something when he says like a traditional distributed message queue does not do it, but like this is an additional feature? That means that it is not a traditional message queue and like event streaming.
I think he's just trying to explain for clarity. Uh, like, uh, I would say it's irrelevant at this moment, but if you ever wonder, uh, like, what's the event streaming platform is versus the distributed message queue, like traditional message queue is, then actually we can say no. But another reason they are talking about traditional distributed message queue is like whenever we are trying to design or initiate any conversation in interview, try to always take minimal guesses or minimum viable design, because you don't know like how much time you will need for it to design completely. So you start with basic assumption. So to keep the whole design simple, he's talking about traditional distributed message queue. So with traditional distributed message queue, he's not trying to complicate it initially.
But Sagar, I have one question here. Uh, can message queue be repeatedly consumed? Is what they're saying. In the traditional, it is not consumed repeatedly. We have pub sub model there also, right?
Yeah, yeah, definitely. Like couple of features are also common in traditional message queue, but here like so basically this question and answer is more like they are just trying to demo like how you can initiate the conversation in any typical system design interview or typical design problem solving. So this has nothing to do with like if this covers all the features or not, but like to me I could see that these are very few questions that they are trying to ask. These are not the all the questions or all the thing that there could be asked. Like there are 10 other things that you can ask, but the interviewer is trying to make it simple. Just to make it simple, he's like repetitively coming back to this traditional message queue. So now, right now, even they mention, right, like the RabbitMQ also includes this like this replay and like repeated consumption and stuff, right? And as you mentioned, like PubSub and repeated this, these are right now do exist, but we are trying to design a simplest version of the queue and not the all featured or exhaustive version that there is in the market. So to design the simplistic version, he's trying to initiate the conversation in this way, like keep everything simple.
Okay, the difference between the simple queue, the I can say like the basic queue and the advanced queue.
Yeah, yeah.
Okay.
Does that answers your question, Tejasvi? Okay. Okay. I think you can go ahead. You can try to read slightly slowly so that we should be able to catch up, or even you will be able to catch up. Yeah. So if you like, if whatever is comfortable for you.
Sure, sure. Candidate, how many producers and consumers are we going to support? Can you scroll? Interviewer, the more the better. Candidate, what's the data delivery semantics we need to support? For example, at most once, at least once, and exactly once. Interviewer, we definitely want to support at least once. Ideally, we should support all of them and make them configurable. Candidate, what's the target throughput and end-to-end latency? Interviewer, it should support high throughput for use case like log aggregations. It should also support low latency delivery for more traditional message queue use cases. With the above conversation, let's assume we have the following functional requirements. Uh, Producers send message to a message queue. Consumers consume message from a message queue. Messages can be consumed repeatedly or only once. Historical data can be truncated. A message queue is in kilobyte range. Ability to deliver messages to consumers in the order they were added to the queue. Data delivery semantics at least once, at most once, or exactly once can be configured by users. Non-functional requirements, high throughput or low latency, configurable based on use cases. Scalable, the system should be distributed in nature. It should be able to support a sudden surge in message volume. Persistent and durable, data should be persisted on disk and replicated across multiple nodes. Adjustments for
So
traditional message.
yeah. So like I think these could be common with whatever we have discussed. Like the earlier one in educative, we were discussing the durability, scalability, availability type of stuff. Here we are just trying to go slightly in detail about configurable based on use case. So the at least one, the semantics we were talking about, right? At most once, at least once. These are for repetitive message consumption if it is needed. So that is nothing but a configuration. So we are trying to make it configurable. High throughput is nothing but we are trying to scale it even further. And persistent and durable is almost similar. Like they have just discussed it in detail. Like data should be persisted on disk and replicated across multiple nodes. Yeah,
And
you can go ahead.
adjustment for traditional message queue. Traditional message queue like RabbitMQ do not have as strong a retention requirement as event streaming platform. Traditional queues retain message in memory just long enough for them to be consumed. They, they provide on-disk overflow capacity, which is several orders of magnitude smaller than the capacity required for event streaming platforms. Traditional message queues do not typically maintain message ordering. The message the message can be consumed in different orders than they were produced.
So
These
number one, just a side note here. Number one distinction between what is streams versus just message queues is order of messages. Streams, the order is always like basically the messages are strictly in order. Like all the consumption and everything, it should be strictly in the order. Only if the messages are missed, then there could be message replays, and in that case even the retry messages would be in order. Let's say if you are going from 1 to 100, like if you have a message marked from number 1 to message 100, message number 100, let's say 10 messages got dropped, 10, 20, 30, the message which has number like 10, 20, 30, 40, up to 100, all these messages got dropped and rest of the 90 messages got consumed. So you will try to retry and reconsume the rest of the messages, which is 10, 20, 30, 40, from some other replica or some other, like, copy of the messages. Even in that, those like even in that retry, the message would be in same order, like 10, 20, 30. You will never be able to consume 100 first, and then 90, and then 80, and then 60, like that. So this is a this is a typical distinction between message like basic message queue or traditional message queue and event stream. So event stream, it's always needs to be in order.
these differences greatly simplify the design, which we will discuss where appropriate. Step 2, propose high level design and get buy in. First, let's discuss the basic functionalities of a message queue. Showing the key components of message queue and simply simplified interactions between these components. Uh, hmm. Pro, Producer sends message to a message queue. Consumers subscribes to a queue and consumes the subscribed message. Message queue in a service in the middle that decouples the producers from the consumers, allowing each of them to operate and scale independently. Both producers and consumers are clients in the client server model, while the message queue is the server.
Yeah,
The
this
cli-
is this is an important like a difference. Now, like so far we have been talking about replacing our client server model, which was in terms of API. We were trying to say that our server will be the one serving the request, right? And like client will be the user. Here both the client and server will become the users of message queue, and message queue will have its own server. So if you see producer and consumer in the diagram above, both will act, or both will try to talk to the message queue as clients itself. Whereas because we are calling them as users or clients of whatever features or whatever APIs the message queue expose. So message queue will have its own backend server. So basically the producer and consumer both are acting as clients to the message queue. So yeah, just like earlier we were trying to like think it as an optional or like an alternative to client server model, right? So in a high level fashion, or in a high level picture, that will still hold true. Like we will generally try to treat the user side as a client, and the backend side has all the server, or like all sorts of like this thing. But if you see here in message queues, it's like if you zoom in just to the message queue, this is more like both are acting as a client to the message queue.
The clients and servers communicate over the network. Messaging models. The most popular messaging models are point-to-point and publish-subscribe. Point-to-point. This model is commonly found in traditional message queue. In a point-to-point model, a message is sent to a queue and consumed by one and only one consumer. There can be multiple consumers waiting to consume message in the queue, but each message can only only be consumed by a single consumer. In the figure 4.3, message A is only consumed by consumer 1. Sagar, can you please scroll?
Yeah, just one. Yeah. Shreyas, do you want to switch with anyone else? I think you have been reading quite a while.
Okay.
Hi, Deva. Good to see you here.
Yeah. Hi, Sagar.
Hi.
Yeah.
Yeah. Yeah. Yeah. Anyone wants to continue reading? Nitika, Sandhya.
I can read.
Okay.
Messaging models. The most popular messaging model are point to point and publish subscribe. Point to point. This model is commonly found in traditional message queues. In a point to point model, a message is sent to a queue and consumed by one and only one customer. There can be multiple one and only one consumer. There can be multiple consumer waiting to consume message in the queue, but each message can be only consumed by a single consumer. Figure shows message A is only consumed by consumer 1. Once the consumer acknowledged that a message is consumed, it is removed from the queue. There is no data retention in the point to point model. In contrast, our design includes a persistent layer that keeps the message for 2 weeks, which allows messages to be repeatedly consumed. While our design could simulate a point to point model, its capabilities map more naturally to the publish subscribe model. Publish subscribe. First, let's introduce a new concept, the topic. Topics are categorized used to organize messages. Each topic has a name that is unique across the entire message queue service. Messages are sent to and read from a specific topic. In the publish subscribe model, a message is sent to a topic and received by the consumer subscribing to this topic. As shown in figure, message A is consumed by both consumer 1 and consumer 2. Our distributed message
So
queue supports both model.
yeah, so I think like couple of things here. I wanted to add some side notes. Like, so when we were talking about, I think I can go about this later. I think that it would be slightly more complicated thing, but yeah. Another thing that I wanted to highlight is, now we will be like talking more in terms of a complicated design. So try to visualize this in a way like this is a traditional message queue. If it is a traditional message queue, one message could be meant for multiple services. So let's say if we want to write down, if we were talking about the likes example, Facebook likes, if we are using the message queue for capturing the Facebook likes, the like could be showed onto some front end platform. It could be stored in the database, and the same like can be used by some analytics service, right? So in this kind of scenario, the same message needs to be consumed by three separate services. And in that case, if our acknowledge once only, like a single acknowledgement or that kind of semantics won't work here. We want the message to be consumed as many times as possible. So in that, like, try to imagine this kind of scenarios. Like here, the message A can go to consumer 1, and the same message A can go to consumer 2 as well. That's one scenario. Like like what I talked about is different backend services, so that will have its own consumer group. So multiple consumer groups could be trying to consume one message. That is multiple backend services trying to consume one message. That's one scenario. Second scenario is from the same backend service, let's say a database service, we can have multiple replicas trying to read the message and trying to store it on their side. So multiple replicas can also try to pull the same message. In that case, we have a single message group, a single consumer group. In single consumer group, multiple consumers are trying to pull the same message A. So this is scenario number two. So try to think about these scenarios, like when we are trying to bring in some sort of a replication, some sort of partitioning, and like distributed architecture. Try to imagine these scenarios whenever they are. I think they will talk more of these things in future, in like further text. But I'm just trying to paint the picture so that it will be easier to absorb. So this is like they were talking about point to point, right? So in point to point, there could be like one on one versus one to many. So here it could be one to many. And it also depends on, like, if we are talking about consistency, right? Like why this scenarios are important, why are we complicating this unnecessarily? The reason is consistency. So message consistent, like our services, sorry, my bad, the non-functional requirement side, if we are talking about our service needs to be highly consistent, then we need something like a one-on-one mapping. We can't have multiple consumer groups consuming, or multiple consumers from one group consuming, and then say that the message has been successfully been stored in any case or in any situation. We can't say that. So in to bring in some sort of consistency, we need to alter between these uh, like these topologies, or these kind of configurations.
So there is no concept of topic in point to point. It gets introduced in pub sub model. Is that correct?
Yeah, that's like according to these folks, yes. But even like in point to point, I think right now they have added the topic just to make it a unique one. But yeah, I think we can, for keeping it a simple design, we can say so.
Okay.
And then if you are trying to make it one to many, right, then we definitely need the topic, right? In point to point, there is actually as such no need, like.
Hmm. A distributed message queue supports both
So
models.
one more thing, my bad. Sorry to interrupt you again. So whenever the consumer is subscribing, it subscribes to a particular topic only. Okay. So whenever like that's a basically at atomic operation. Like a subscription is always to the topic. It's not to the queue. Okay. So like that's why like they are talking about the PubSub model. Like it's a very like imperative thing in PubSub model is you're publishing to a topic and you're subscribing to a topic. it's never to the queue. Like, so like whenever you're like, I'm just trying to like the language that you could usually be talking about it. But yeah, so generally, like, this is a typical language you will see. Yeah, go ahead.
The publish subscribe model is implemented by topics, and the point to point model can be simulated by the concept of the consumer group, which will be introduced in the consumer group section. Topics, partition, and brokers. As mentioned earlier, messages are persisted by topics. What if the data volumes in a topic is too large for a single server to handle? Our approach to solve this problem is called partition, sharding. As shown in figure, we divide a topic into partition and deliver message evenly across partitions. Think of a partition as a small subset of a message for a topic. Partitions are evenly distributed across the servers in the message queue cluster.
So let me okay, so partition, so this is small subsets of messages. Is like, we were taking an example of 1 to 100 messages earlier, right? Let's say the topic is Facebook likes, so the like is the name of the topic, or FB like, FB underscore like is the name of the topic. And there are 100 messages. So what partition essentially uh, is nothing but we will push, let's say, even number of messages in partition 1 and odd number of messages in partition 2. So eventually each partition ends up holding just 50 messages instead of 100 messages. So that way we are basically load balancing in between the single topic. If we keep all the messages on a single queue, and the size is full, then we need to somehow break it down, right? So we try to keep it like we try to like dissipate the load by having more partition. This is nothing but the data, like something similar to the database sharding that we do. Or like, we are trying to introduce more partitions just to keep the load or keep up with the load, or just so that our total messages won't exceed individual queue size at any particular partition or any particular server. So we often try to break it down into two, three, or whatever. And in between those three or four partition that we are creating, now we need to distribute the messages in themselves. So let's say if I'm talking about even and odd, I'm using a basic hash function. That hash function is just modulo 2. And that, we, let's say we are using consistent hashing, then in consistent hashing the hash function could be just modulo 2 or like even odd kind of function. So it will just try to break every single message or every single key id into two. If the id is even, then it will try to point to partition 2. If it's odd, it will try to point to partition 1. Just that. This is nothing but simple load balancing, or simple and this whole thing is could be framed as consistent hashing, or like the kind of sharding we were talking about earlier. Like, so who does that, who owns all this consistent hashing logic and like distribution of messages? It's the broker. That's what we will see going forward. So whenever we are trying to distribute the messages, whenever we are trying to route the messages to appropriate partition in the same topic, we will actually point it to the broker. So broker actually does that basically, or it holds the information related to this, like which message is held by which particular it's supposed to be held by which particular partition number. And why we are discussing about it? Typically in a high scale distributed systems, a particular topic could have 500 or more than that partitions. So let's say if it's Facebook likes, then a Facebook like message queue could like very easily have like thousands of partitions. So in that at that scale, or like at a given second, there could be millions or billions of Facebook likes coming in, being streamed from Facebook clients all over the world into Facebook servers. So think of that scale. Like, and for that we need the brokers. Like the broker is a dedicated service, or it could be a dedicated component in that case. Does that make sense? This is nothing but a Kafka broker again. Like Kafka, like a broker is often actually typically talked in terms of Kafka brokers. But yeah, feel free to interrupt me and ask any question. But yeah, like to sum or summarize my like what I said is, uh, like we need scale. We need to maintain the queue size like as an infinite size, um, without running into the limits of individual server or individual machine. For that we need to break it down into multiple partitions or shard the topic. While sharding the topic, we need to distribute the messages in some fashion or with some algorithm. That algorithm could be the consistent hashing algorithm. It will have its own hash function. And who does this job is the broker. So that's why actually they are trying to talk about topics, partitions, and broker all together. Like, so we have topics. To maintain the scalability of topics, we need partitions. To be able to do the partitioning thing, who manages the partitions and who manages the distribution amongst the keys, it's brokers. Okay, you can go ahead.
Partitions are evenly distributed across the server in the message queue cluster. These servers that holds partition are called brokers. The distribution of partition among brokers is the key element to support high scalability. We can scale the topic capacity by expanding the number of partition. Each topic partition operates in the form of a queue with a FIFO first in first out mechanism. This means we can keep the order of message inside a partition. The position of a message in the partition is called an offset. When a message is sent by a producer, it is actually sent to one of the partitions for the topic. Each message has an optional message key, for example, a user's
uh,
ID.
give me um uh, give me a second. So I need to actually, I wanted to explain this one as well. I think we should highlight this part. Keep this in mind. The position of a message in the partition is called an offset. So this is not to confuse with the sequence number I was talking about. So each message could have its own sequence number. And let's say a topic, we were talking about 100 messages being sent using queue, and we are trying to now distribute those 100 messages in, let's say, two partition, even partition, odd partition. Now in the partition itself, let's say if it's an even partition, the partition needs to know the serial number of the messages it holds in itself, and the scope will be just limited to partition 2. In that scenario we also need to again give a sub numbering. Like 2 will be the first message in partition, even partition. 4 will be the second message. 6 will be the third message, and like that. So this additional like numbering that we are trying to do, like the ordering we need to do in the partition in itself, that is something called as the offset. uh, but the sequence number we have on the messages, that's for the producer and that's for the consumers. So like at a global scale, at a very 10 feet overview or high level overview, we have sequence numbers of the way the messages are produced and enqueued. And that has nothing to do with the offset. Offset is just meant for maintaining the order of messages in a single partition. So going forward, whenever we are trying to deal with any kind of fault tolerance, any kind of like availability or any kind of thing, then we will only be like keeping zooming it on to a partition. So everything will be in terms of this offset, because offset will be the ordering of the messages in that particular partition. If that is done right, then queue is nothing but collection of all such partitions. Like, so a single partition, we will try to, like, whatever like discussion that will follow, try to that will be in just in the context of single partition. The offset, the numbering, the retry, the acknowledgement, everything. So keep this in mind. Like, again, we are trying to I'm just trying to break it down, and as we go by and as new components come into the picture.
So Saga, just question. So you mean to say offset ID is different one and the sequence ID is different one, is it?
Yeah, yeah.
Mm, but when consumer are consuming the data, then that time there is a offset ID, like at what, like where, like how much data he has consumed, and those things are tracked by offset ID itself only. So
That is because our consumer is talking to a partition, right?
yeah.
A particular, but the schema of the message, consider this scenario like, you are talking on Google Meet. Let's say we are talking on just Jitsi Meet. The messages which are initiating from my side, let's say I said 1 2 3 4. For that, the Jitsi Meet creates 4 messages. These four
Mm,
messages are initiated from my side, and those will be numbered. One will be numbered as 1, 2 will be numbered as 2, 3 will be numbered as 3, 4 will be numbered as 4. Okay. Now I want you to hear those messages 1 2 3 4 in the same order, or listen to the receive those in same order, or like, sorry, my bad, hear those messages in the same order, like 1 2 3 4, because I utter 4 at, let's say, 7:15. I utter 1 at 7:15. I utter 2 at 7:16. I utter 3 at 7:17, something like that. Let's say in this like with timestamp, I'm doing this.
mhm.
So that's something called a sequence number. Now, if you are like enqueuing these in two partitions, then possibility is 1 and 3 could be stored together, and 2 and 4 could be stored together. If you're storing 1 and 3, then possibility is you receive 1 first and then you receive 3. So you will add offset value as 1 to one particular partition, and offset value of 2 to one particular partition. So on consumer side, you will have two consumers. One consumer will be consuming from the even partition, one consumer will be consuming from the odd partition. In each context of context of each particular consumer, they will just try to track, I receive first message from partition, even partition, I receive second message from even partition. Similarly, the other consumer will receive the first message from odd partition and second message from odd partition. That's that the first message and the second message that each consumer is trying to deal with, that's nothing but the offset.
What's the purpose of sequence ID here then? Because sequence ID,
Sequence
if we are
id
not consuming in sequence, then again we are talking about the offset one.
no, no,
Then
no. So like once you receive, so now your consumer 1 has just received 1 and 3, your consumer 2
hmm,
has just received let's say 2 and 4, right?
hmm,
Now you need them to be again like combined back, right? On your side, on your Jitsi client, on your side will need to
hmm,
collect it like together, right? And while it is collecting
right.
together, while it will be showing the messages or like playing the message on your side, now it will use the message sequence number. So it
Okay,
possibility
but
is it will receive 4 first, and then it receives 3, then it receives 2, and then it receives 1, right? Like the
mm,
client, like the end to end like the front end client, or like end to end client that I'm using, user client I'm talking about.
mhm.
To while
Okay.
Yeah, so while playing it back to you, it will then try to reorder it on its side.
So offset has the unique number, or it may be the repetitive in the
Offset
each
is unique to Offset is unique to the partition only,
partition. Partition. Okay,
just the
then that,
partition.
yeah, got it.
Yeah,
Like it is like a file structure, like
yeah,
folder, file
yeah,
folder.
yeah.
Okay, got it.
While the sequence number has to be unique for the whole uh, architecture, or for the whole
Exactly.
system.
Okay.
Okay, got it now. Hmm.
Sagar, why do we need, like, I did not understand, why do we need like offset at all? Like, if we just have a sequence ID, then like from topic A it will go to partitions and then it will go to consumer and we can receive it in a same sequence, right?
I think same sequence means it is like the sequence it received. Like he said, right? There is a even number queue and odd number queues. Even number partition and odd number partition. The consumer, one consumer can get only even number, and other consumer can get only odd number, right?
Yes.
So that time you need the partition, like, for the even number partition it is 1 2 only, and odd number partition it is 1 2 only. But like how you will consolidate the final message? For that you need sequence ID.
Sequence number.
No, no. My question is reverse. Like, I get it, like the sequence ID, but why do we need like offset?
You also need the messages. Let's say in a scenario you need the messages to be kept in same order. We are talking about streaming platforms, right?
Yes.
So in streaming platform, let's say I'm using timestamp as a way to differentiate between various partitions. So you need the message to be ordered in timestamp itself, right?
Hmm.
So let's say for this meet, you said I'm talking to Sandhya. Let's say I want some messages to be sent to Sandhya. I said 1 2 3 4 5 up to 10, and 5 minutes ago or 10 minutes ago, you had said something like 101, let's say 90 91 92 93, something like this. If there is no ordering, and if let's say by chance both of these set of messages got categorized onto got put into same partition, chances are that like these messages will mix up, right?
But we have sequence ID, right?
Yeah, so technically your client will be able to separate, but at this moment there is no need of those messages to mix up, right?
Okay.
Because the timestamp on the current messages is 7:15 to 7:20, something like that, and what you said was way before that. So let's say I'm using the partitions, or like distinguishing between the partition on the basis of, let's say, timestamps, or like some sort of a time based
Chunks,
thing.
like imagine there is a big message and chunking that message in
Yeah,
that way.
yeah. Oh, that's a better example. Yeah. So so if you want to keep the messages in a particular partition in the same order, then we need the offset.
Okay.
Let me think of an example. I think right now I'm not able to come up with a right example to tell you, but there will be scenarios in which the consumer, every single consumer, needs to give me 1 second. Yeah, there could be scenario in which every single consumer need to consume the message in the same order it was published, or like that. Let's say any particular scenario like this, where the order matters to a particular to consumer groups or consumers, then you need basically then you rely upon the offset. That's one scenario. Another thing is when you're replaying, the replay always takes place on a particular partition. So while replaying, how would you know which message has been consumed and which message has not been consumed? So you need some unique IDs which are specific to a particular partitions. That unique ID is nothing but the offset.
Okay. Got it.
So it's nothing but a local level versus global level. So the sequence number is more at a architectural level, at a queue level, or a distributed queue level, and the offset is nothing but a per server level. Like, and let's say we have thousands of partition per topic, and we have thousands of topics. So in total, let's say we have millions of partitions like this. So all these millions of partitions, how would you actually try to keep the sequence number? Like, you can't, the sequence number is irrelevant in that case, right? You need to zoom in on
Mm-hmm.
local values or local unique IDs to identify the replay or like the failed acknowledgements or all sorts of thing at a particular partition level. So you need a partition to give the numbering itself for itself.
Okay, that makes sense.
Any other question?
Can we stop here today and continue tomorrow?
Yeah, I thought of saying like if it is continuing, I need to drop.
Oh yeah, yeah. I didn't keep a track of time. Yeah, okay. I think we can stop. Yeah, yeah. Thank you, everyone. Yeah, let's continue from tomorrow. Let's continue from this topic tomorrow.